Our project is a self-aligning solar panel mount that a solar panel can attach to and follow the position of the sun throughout the day. Such an ingenious mechatronic system can prove as a practical application for obtaining ecologically friendly electrical power.
A total of 2 breakout boards were used for the project, and they were both bought from Adafruit. The first is a GPS module, which is used for finding the latitude and longitude of the current position, along with the current time and date. The second breakout board is an accelerometer module with a built-in magnetometer. This is used to align the upper structure in the east-west direction. The magnetometer is required because the solar panel is a stationary object, so the GPS cannot provide us with direction. The 2 actuators that we used were standard RC servos. We chose them because they could be powered by the Arduino rather than an external power source. The full-scale model will require us to use separate motors for the increased torque, and they would also be powered off of the solar energy rather than a power supply.
The first segment of the loop block is to align the base of the mount so that the panel is tilting along an east-west axis, since that is the direction that the sun's path takes. The magnetometer is used to get magnetic field measurements, which the Arduino can use to calculate the current heading in degrees, which will give the mount its direction. The magnetic field measurements are vectors in the X, Y, and Z directions. So to get the current heading, the Arduino performs trig on the X and Y vectors. The corresponding angles and directions are 0 degrees for north, 90 degrees for east, 180 degrees for south, and 270 degrees for west. Each time the Arduino reads the heading, the servo in the base is incremented either clockwise or counterclockwise, depending on which will provide a shorter time to get to the proper alignment. And it continues to increment until the heading is either 90 degrees or 270 degrees. At this point, the servo in the base is disabled and the tilt servo is enabled so that the panel can tilt.
The necessary tilt angle is based on the time of day. The sun moves approximately 15 degrees every hour with a 0 degree position at 12 o'clock noon. The GPS module provides data for current latitude, longitude, and the date and time. The time and longitude are used to convert Greenwich Mean Time to local time. The latitude and date are used to determine sunrise and sunset to set the position of the panel at the start and end of each day.